Good evening, good morning, and good afternoon from wherever you're at in the world. My name is Jesse Spangberg. I'm a senior network and design engineer for AT&T. I also go by the name Azul Onyx on Twitter and Discord. I'm here to talk to you about rewriting open source tool iLEAPP. Who am I? I work for AT&T for the last 5 years. I have nearly 20 years of military experience. Also completed a master's in digital forensics and have several certifications. My social links are listed there above. Best they reach me out on either Discord or or Twitter rather. I also run the @DFAR Phoenix Twitter handle. My website's digitalforensics.io, and my email address is there listed as well for anyone who wants to try to get a hold of me. All right, first disclaimer: I'm not a developer, so the code may not be ideal. So please let me know if there's any issues you see or noted. Also, the opinions expressed in this presentation and the following slides are solely those of me and not reflect AT&T or the military for that matter. All right, first, some background. So what is iLEAPP? iLEAPP is an iOS logs event and protobuf buffer written by Alexis and Yogesh. It's written for Python 3.7 plus, so 3.9. 3.9 is preferred. Supports parsing a wide variety, about 90 different artifacts. There's HTML reported. It's also open source. If you've ever used Autopsy, it is the iOS parser for Autopsy, which is created by Basic Technology through Brian Carrier. It's a great tool. If you're not following Alex and Yogesh, you should go follow them on Twitter. Their handles are on the screen. All right, so there are a family of tools that are created either by Alex or the community. These are all listed here. There's iLEAPP, RLEAPP, ALEAPP, VLEAPP, and CLEAPP. And one iLEAPP, which is one that I'm working on, does iOS logs. The other one, RLEAPP, is returns, ALEAPP is Android, VLEAPP is vehicles, and C is Chrome. RLEAPP is the newest one, being returns, and those are warranty returns, where you submit a warrant and the Apple or Google or whoever you send it to sends you back a return of the user's data, and that one supports some events from warrant returns. CLEAPP is also another really current one. That one happened during the magnet forensics CTF earlier in the year, and Mark McGinnon, I'm hoping I pronounced that right. Mark McGinnon is the one that actually copied iLEAPP and created one for Chrome. All right, so this project has three objectives, main objectives, and that's documentation, which I'm going to talk about each one of these: documentation, installable, and framework. As you noticed in the previous slide, there are about 6 different ones. 5 different ones for the different tools. They're all based around the same concept of iLEAPP, and they're all the same base code, but they're actually separate different projects. First, for documentation, the original, when I started to do the project in beginning of last year, this is in January of last year, I originally wanted to read the docs. I think it's very simple. There's an example on the screen to put all the documents together, and it'll, using Sphinx, it'll actually create documents for you, and then take all of your documented code and make it so that it's usable and pre-documented. And this is where I'm going to go. This was started, but I've kind of at the moment have stopped doing this to work more on the actual underlying code base. What I realized is the code was not working for Sphinx to actually auto-document itself. So fixing the code should help creating the Read the Docs website, which the plan is to have examples, code information, links, all that information in the one place on Read the Docs website. Next one is making it installable. So iLEAPP actually has a binary that on Windows you can use. So Autopsy uses that binary and creates all of the artifacts from this precompiled binary. However, it doesn't install directly as a Python project. A lot of tools I've noticed do not do this for digital forensics. So one of the things I want to do is make it installable through pip. This already works. It's actually I'm using this actual setup. This is part of the setup.py, and it installs, and you could run it and use it just as it is. So framework. So merge all to a common base. So each one, iLEAPP, RLEAPP, aLEAPP, vLEAPP, cLEAPP, they're all different projects, and they're not really tied together. And one of the ideas here is to create a framework that all these can be tied back to so they're all the same, from the same code base. Because the problem is, if you modify something on one, you have to go back and modify the other ones, and they become out of sync. So one of the major things I want to do is create a way to do that, and some of that's going to be coming up here shortly. I'll talk about how that's going to happen. The other thing is using Python subpackages. That's one of my ideas, but that's creating for each one iLEAPP, RLEAPP, aLEAPP, vLEAPP, cLEAPP. So you'll have xLEAPP, which will be your code base, your GUI, your CLI, all that's going to be contained. It won't contain anything for any of the artifacts or specific for each platform. Then there'll be subpackages for each platform that you can install separately or together. And then from there, you'll have your artifacts will be the base artifacts. Any of the completely open source ones will be inside of the base package. And then there'll be a second package you have to install for anything that has a license conflict where we can't distribute with iLEAPP due to some license issues based on how someone licenses their program. We've run into that in the past. This is to say, hey, yes, you could use these artifacts, but you must install them by yourself. We cannot distribute them to you. And also simplify the artifacts for any contributors that want to add more artifacts to the program and extend from 90 to 120 or whatever people want to find. There are a lot of artifacts out there for each one of these different platforms. So I'm going to use this example for an artifact. This is the GeoD application artifact. This is one of the ones I found during my thesis, during my master's program. So on the one side, the old artifact is 45 lines, and the new artifact is currently 35 lines. You can notice the differences here where different imports, there's less imports on the new one. There's also less stuff dealing with reporting directly in the artifact. And it's specifically, so here you're looking at specifically the artifacts themselves. And then to add an artifact, like right now, if you were to go to iLEAPP and add an artifact, you would have to do these two things. One is you add a Python script to the folder scripts/artifacts, and you'll make two changes to the iLEAPP_artifacts.py. The two changes which I've highlighted for this previous artifact, for the GeoD applications artifact that I previously shown, you'll have to import it, and you're going to have to add it to the search dictionary at the bottom. They're in the same file, you just have to do it in two places. The first one imports your artifact itself, so it can be found by the application. The second one, the to search, is the list of files that your artifact will process. All right, the new method is slightly different. No, well, more different. Primarily, you're going to create a Python script, place in plugins. Okay, same concept as before. However, what you want to make sure is you add in a name, which is what the artifact's name is. This will show up in the reports. A category of that artifact. There's no set number of categories. You can just name it whatever category you think it fits in. It could be one that's already been used, of course. A web icon. This one is specifically for what icon shows up on the reported. If you change it here, it will change on the report as well. I did show it in the previous slide, but there's actually one more thing you have to do. You have to go to another file and add the web icon. Here you're doing name, category, all that stuff's done in one section. You can also add report headers. Here I have the ones for this report. If you only want key value as your report headers, you don't have to do anything. It automatically takes it. All right, the report changes. Primarily the same. There's some differences in the bottom. Primarily these are trying to keep these the same, and you can tell on to the navigation, all the web icons on that side of the screen. But primarily I'm trying to keep the same format, which was already done in iLEAPP. Most people already know it. So, however, there's one big change. The background to the HTML report is generated through Jinga, which is part of the Flask program. So this is another script language, and it takes all of your HTML out of Python and puts it into Jinga, so it's separated, so you're not worried about it. This does all of your artifact pages. Anything that's on the report is done through Jinga, and there's a whole folder for the report in and all the templates. And even you can even add specific templates for each individual artifact. It's kind of in a very early stage, but you'll be able to change the template from a normal table template to something else. All right, speed changes. There's not much in speed here. Using about the same number of artifacts in the same artifacts, you've got about 36 seconds to 32 seconds. I was hoping it would be faster, but I'm still working on some of the underlying coding, so hopefully this will get speed up. But we'll have to see as more artifacts are transitioned over. I can test them to see what the speed's going to be. How you can help. First, you can go to the fork. It's at iLEAPP. Pay attention to the different branches I have. The second thing is that you can go to Alexis' original project as well and take a look there. Things that need to be worked on. Artifact migration is a new format. There are a lot of artifacts, and because there are a lot of artifacts, it's going to take a lot of time to transition them over. A lot of artifacts just need to be removed. A lot of information has to be removed from them, and then added to metadata and just consolidate it into one location. Optimization for calling artifacts. Right now, I think it's calling too many times. I haven't really got a chance to figure out why it's doing that. Document and devise the code, of course, because that's why I started the whole program. And then the package support, which I've done initially, but there's always room for work there. The last thing not on this slide is tested. Really need like a test framework. I started to work on it, haven't got very far in it, but if you're very good at Python unit testing, let me know, because we do need some testing for it to make sure when new artifacts are added, they are tested, and we make sure that they're going to output the right information to the program when they're accepted into the code base. All right, and then about me again, in case you missed it the first time, and all of my social links are on there as well. Want to reach out, please hit me up on Twitter, Discord, on the website. Find me wherever you can, and hopefully everyone has a great rest of Deadwood, and I will see you later.